All right, so I don't think we can finish off this first session without getting at least one pinball in here to actually just drop down and test with our flippers. So let's do that. And I should have mentioned at the very end of the last lesson that if you do want to make the transparency totally off for that sprite, what you're going to do is just click on the color over here and take the opacity down to 0. And you could have also set it to full black as well if you anticipate having an all black background. Probably not the case though. All right, so you know what? Let's go ahead and add one sprite out here. I've got a couple textures in the library. This first one is kind of your maybe your more standard looking pinball, and I'll show you guys why this is actually not the ideal one that we want to go with. Something close to it will be nice, but I'm trying to position that over top there. All right. And all right, so we'll just leave that right there. Let's go ahead and take one of our flipper classes. Actually, let's take our flipper stop class because it's the more simple of the two. Duplicate it, and we're going to call this ball with an L, not semicolons. There we go. And then be sure you actually select this. Sometimes if you duplicate things, you end up editing the one that you duplicate from. Gotcha there. And change the class to ball. And what we're also going to do here is, of course, give it a category bitmask of ball. And if you remember, we should have already put that in here under our main game class. There it is. And then we want to detect when the ball, well, we want the ball to actually collide with the flipper, right? And we could also test the contact between the two of them. You know what? I'll leave that in here for right now, although, you know what? Yeah, just leave it in there for the moment. We might also want to test when two balls end up contacting each other. We'll put these in here as question marks for now because I'm not sure if we actually will do that. But for sure, we want the two to collide with each other. And the same thing is true with a ball and another ball. And that should be good enough for now. Of course, in our game scene, we do need to make sure that we call that setup statement. So come over here, and you're going to write else if let, and let's call this some ball. That'll be a ball. Ball. There we go. That should have set it up. And then we're going to have a kind of a main ball here. Even though, you know, for the time being, we probably will just have one anyway. But the reason I'm going to kind of track a variable for having a main ball is we want to know when to possibly move the screen up or down, you know, if the ball exceeds it. And really, that's probably just going to be the case for the Apple TV, unless you anticipate having tables that are bigger than the portrait mode of your phone or your iPad. So create a variable over here. We're going to call this main ball, and this is going to be the ball type. And you can just set this to being ball with just 2 parentheses after it. I hesitate to say that's initializing it, but I guess it is. But what we're going to do is when we find a ball called main ball, and that's what we're going to label our ball, we're just going to basically make that main ball variable equal to that particular node that we found. So to do that, inside of, again, when we're setting up our children, what we're going to do is write if, and then some ball dot name equals main ball. Then what we'll do is say that our main ball is going to now equal some ball. Got it? Of course, we do need to head over here to our game scene file, and again, just working with the iPhone for now. Put in their main ball. Although if you did want to, you could copy all these objects out and paste them to one of the other ones. Just keep in mind with our TV version, at the moment we don't actually have anything yet that is making our flippers go back down. Okay, so that's kind of why we're going to keep testing with the iPhone for just a little bit, but we'll correct that soon enough. So anyway, we've got main ball here. We do have to set the custom class of this to being ball. And then once we've done that, I suppose we could give this a quick little test. It's oh, and you know what, I'm sorry too, one other thing, we do need to make sure that we give this ball an actual physics body, which we've yet to do. And the reason I'm not hard coding in any sort of physics for this is I do want you guys to be able to change them, as you feel you need to. So this is going to be a bounding circle, of course, and then you do want this to be dynamic, and of course you want that to also allow for a rotation. If you don't put if you don't allow for a rotation in there, it certainly does not move how you would expect. And then your friction and your restitution are really going to be kind of up to you guys, I think. What I've done is, and I'm actually just referencing some of my other notes over here. It looks like I have the friction set to, well, the defaults, and the restitution set to the defaults as well. So I guess there's no change. But if you set this to 1, it's kind of treated more like sandpaper. Okay, oops. I think I just removed my physics. And then if you set this to 0, it's closer to what you would expect from a pinball, right? Or a piece of ice, essentially. Really smooth and slick. But I've been working with it at 0.2, obviously, and apparently. So we'll leave that as is. And then the restitution, for a while I had that set down to 0 when I was testing this, and I decided to actually flip-flop back on that. I guess I put it up to 0.2 again, and that's the bounciness. And I believe the reason that I set it back up a little bit is because watching some videos, I did notice that the ball, even though it is this like chrome metallic ball, it tends to bounce off of more things, and it's not really the ball that's doing it; it's the material that it's bouncing against. But I thought it still looked a little bit more real if I gave the ball a bit of a restitution as well. And then as for the mass, that is something that I tinkered with. Now, what Sprite Kit's going to do is they're giving you the mass based on the object body itself. So you can see their flipper has got a little bit more of a body to it, right? So it's got a mass of 0.4543. But keep in mind, in the real world, this is more like a piece of plastic, and it probably is maybe, it weighs as much as the ball possibly could, right? Ball is a big, solid piece of metal, right? So I was tinkering around with setting the mass up to something more like 0.25. Okay, don't worry too much about all these other numbers over here. So that's going to be something that really affects how the ball plays in the board. So that it's something that you might want to consider changing if you don't like how it is working. And the more mass that has, the more the flipper is going to have to work to send the ball back upward. All right, so I believe we could give this a quick test. Obviously, what's going to happen is the ball is going to fall through these flippers and just be gone for good. But we can watch it happen, and you know what? It might have actually already left us, because things kind of kick in during that transition. So, well, that brings us to the next thing that we have to do, which is, of course, account for that. So if the ball goes below, and we'll do this inside of our update statement, if it goes below a certain point, then we're just going to take that ball and bring it back again, right? So what we'll do is, and we can do this outside of here, because at this point, we don't just, well, for the main ball at least, what we can do is just say if main ball.y is ever less than 0. Now, at some point, when we have, like a multi-ball mode, we're going to want to scan through every ball, and if it goes, outside, then we'll put it somewhere else. But again, we're just kind of getting things started. All right, so what we'll do is we'll say main ball dot position dot y equals, and we'll put this up at like 1079, a little less than 1080, and then put our main ball dot position dot x. Set that to, what's funny? This is, you used to not be able to hard code in values like this. You used to have to do this. That's so odd. It must be something they've changed recently. It used to be you'd have to go CG point make, and then you'd put in here like 720 for where the ball is going to go on the X, and then 1079. But I guess my brain was on autopilot when I wrote that code, and it turns out it works. So anyway, you learn something teaching, don't you? All right, and then I'm going to reset the velocity. So, that basically if you're just going to drop the ball back at the top of the board again, it's not going to maintain any of its previous velocity, right? That doesn't make any sense. And then I think we should be good to go. So the only thing that I've put an error on here is, there we go. Now this you could always do. You could always put in here if you could always test to see what the value of the position on either the X or the Y was. You just didn't used to be able to set the position like that. And let's see. Let me just double check to see where 720 is, because I might have put in that number from testing on the Apple TV. All right, that should about hit the flipper. Maybe, to be sure, we'll put that at 700 initially and then 700 over here. Okay, let's give it a shot. Oh, right. Yeah, I've only got it starting at about midway up the screen. But anyway, there you go. You can see that it certainly is working. All right, so I can really kind of nail that thing out of there. While you're testing this, what you might want to consider doing, so you don't send the ball just floating off into space, is putting some kind of dummy barriers outside the screen. So bounding rectangle, you don't want any of those to be on. And when you're setting just kind of dummy sprite to have a physics body like this, get it in the shape that you want it first, and then apply the bounding rectangle to it. All right, so let's get all that off. And then I believe by default these the ball should collide with these physics bodies, because we aren't, let's see. Okay, yeah, you can see that they are. All right, so now we can kind of keep it in our little world. And I want to kind of roll down some. So you really need some bumpers back here to be able to, keep the ball. Here, let's put one in. And we can rotate this guy something like this. Just so I at least have something that I can kind of trap it into in a V shape. And here we go. Bounding rectangle again. Turn all that off. All right, so now when it comes down, I should be able to keep it there. Okay, there you go. And then, well, simulator. Chalk that one up to the simulator. Again, not the physics that you get on the actual device, but kind of close enough. So one thing I want to point out is that the this is not a natural look for the ball spinning around like that. Okay, so in some sense we've kind of almost hard-coded in this shine on it. Okay, see that reflection right there? And what would happen in real life is, the light source hitting this kind of chrome ball is not changing. Okay, so no matter what the rotation of the ball is, this reflection is always going to be there in that one particular spot. So as a little workaround, what you might want to do is go back over to here and find your ball. Okay, set it to one of my other textures that I've added in there. This one is a very dark ball. And then I'm going to put in here another sprite. I call this ball overlay. And I've actually got a texture named ball overlay, which is just, you can kind of get a better idea of what it is. Looks like if I put it over top the red, it's just the kind of chrome part right there. I mean the reflection of it. And I'm going to actually make that a child of the ball. So over here in my parent, I'm going to say that you are now going to be a parent of the main ball. Okay, and I want to set the position of this to just exactly 0 and 0, because that's those coordinates are within the ball itself there. And what you'll see is that the ball still does exactly what it was doing before. If we were to test this, it's going to spin around. So it almost looks even worse now, right? Okay, but what we're going to do is go inside of our update statement, and we are going to find, there we go. We're going to look for any ball. All right, so we're going to say else if let ball is going to be, our ball equals node as ball. And in that case, for, we're going to say child node in ball dot children. So essentially kind of what we're doing right here, where we said for node in self dot children. Now what we're saying is for child node in ball dot children. If we detect a child node in there, and every SK node has a Z rotation property, so we can access that right away, then we're just going to say that the Z rotation is going to equal the opposite of the ball itself. Okay, and when you do that, what will happen is that little chrome part will stay as is, but the ball will still be rotating. Okay, that's important. You do need to have it rotating. And see how that's working. And it's a little hard to tell in this particular zoom. I can move everything up and zoom in a little bit, but you will notice that part of the original image for the ball, not the ball overlay, you do actually see that still rotating, and that helps a lot, I think, too, just to make it seem like the ball isn't just kind of like too floaty, you know. And as far as odds and ends go, a couple last things. Oh, you know what? We need to go over to our flipper class, our flipper stop class, and our ball class. And on each one of these, go ahead and put this line in there. So that's going to be physicsbody.uses precise collision detection. That's probably what accounted for that the ball occasionally slipping through the flipper that we saw. So do that just after each one of the contact test bitmask statements, so all of those. And then finally, one last little thing. I would make sure that the overlay that you put in here, just put this at a Z position of 1, because I believe by default it kind of gets added in at the same depth as just this image back here, and then so what'll happen is like you might not see it. It just depends. It's almost kind of random at times. So anyway, if you've done that, I think you'll have a good working version that you can test in, of course, the simulator, and then your iPhone, your iPad. And next session, what we're going to do is tackle lowering the flippers with the TV, the new Apple TV apps, and of course, much more awaits in session 2.